Hello students, welcome to this session. In the previous video, we have discussed some examples on the basic concepts of vector calculus. Now let us deal with some more examples on the basic concepts of vector calculus. Now there is an example. Show that f bar equal to xi plus yj divided by x square plus y square is both solenoidal and irrotational. Means they have given some vector and we are required to show that this vector is both solenoidal and irrotational. First, let us recall the definitions of solenoidal and irrotational vectors. A vector f bar is said to be solenoidal if its divergence is 0, and a vector f bar is called irrotational if its curl is 0. That's why first let us compute the divergence and curl for the given vector. If the divergence of f bar reduces to 0, then we can call it as solenoidal, and if its curl reduces to 0, then we can call it as irrotational. First, they have given f bar equal to xi plus yj divided by xi x square plus y square. The same thing, once you go for individual division, we can write it as x divided by x square plus y square into y plus y divided by x square plus y square into j. Since the third component is not there, we can write it as 0 into k. Now it is of the form f1i plus f2j plus f3k. Then the divergence of f bar is given as the dot product of del and f bar, and that is given by do f1 with respect to x partially plus do f2 with respect to y plus do f3 by do z, where f1, f2, f3 are the components of the vector f. Now first you have to differentiate that first component f1 means this one partially with respect to x treating y as constant, that is x square plus y square. Keep the denominator as it is, differentiate the numerator with respect to x minus, keep the numerator as it is, differentiation of the denominator with respect to x is 2x. In the same fashion, we can differentiate this one with respect to y partially, we will get this one. So this might be y naught y square, that is going to be y, and this one is going to be 0. Now, once you take the LCM, the x square plus y square, this is x square, y square I'll write as it is x square minus 2x square is minus x square plus x square I'll write as it is y square. So it is going to be y into y is 2y square, that is y square minus 2y square is minus y square. They get cancelled in the numerator, therefore we get 0 divided by x square plus y square whole square, and its value is going to be 0. Now, since the divergence of f bar is 0, that's why we can claim that f bar is a solenoidal vector. Now, let us call the curl of f bar. Now, curl of f bar is given by del cross f bar, that is a determinant of first two elements are unit vectors I, j, k. The second two elements are the components of del, that is do by do x, do by do y, do by do z. And the third two elements are the components of f, and the components of f are x divided by x square plus y square, y divided by y square, x square plus y square, and the third component is 0. Once you evaluate this one, determinant, the first two are going to be 0, that is I into, derivative of this one is 0, derivative of a constant is 0, minus j into, leave this row, leave this column, derivative of 0 partially with respect to x is 0, and this term is free from z, again it's a derivative with respect to z partially 0, plus k into, leave this row, leave this column. If we differentiate this one partially with respect to x, we get minus 2xy divided by x square plus y square whole square, and if we differentiate this one partially with respect to y, minus or minus becomes plus, that is 2xy divided by x square plus y square. These two will get cancels, again it seems to be a 0. Therefore, in this case, curl of f bar is also 0. That's why we can claim that the given vector is also irrotational. Earlier, divergence is 0. That's why we can claim it is a solenoidal vector. Now, its curl is also going to be 0. That's why we can claim that it is a irrotational vector. Now, let us consider the next example, and it is going to be like this. if a bar is a constant vector and r bar equal to xi plus yj plus zk, then show that 1 by 2 times curl of a bar cross r bar equal to a bar. Since once you look at the requirement, first of all you have to find a bar cross r bar, then you have to find the curl of that vector, then you have to try to prove the required. And since they are given a bar is a constant vector, let it be a bar equal to a1i plus a2j plus a3k, where a1, a2, a3 are constants. And we have r bar as xi plus yj plus zk. Therefore, consider a bar cross r bar. The first, it is a determinant of first two elements are ijk. The second two elements are components of a, that is a1, a2, a3, and the third two elements are components of xyz. Sorry, components of r, they are xyz. Once you evaluate this one, we find I into, that is a2z minus a3y minus j into, that is a1z minus a3x plus k into, that is leave this row, leave this column, that is a1y minus a2x will get. Now this is the cross product of a bar and r bar. Now we have to consider the curl of this a bar cross r bar. Now curl of a bar cross r bar is given by, it is del cross a bar cross r bar. Now I, j, k, they are the elements of the first row of the determinant. Now the second row elements are the components of del. They are dou by dou x, dou by dou y, dou by dou z. And the third row elements are the components of a bar cross r bar. They are given here. There, that is given by a2z minus a3y, that's the first component. Then a1z minus a3x, that's the second component. The same thing, that is when you multiply the negative sign, this becomes minus and this becomes plus. And the third component is a1y minus a2x. Now let us go for expansion of the determinant, that is I into, operate this one with respect to y partially, therefore you will get a1 minus, and operate this one with respect to z partially, again that becomes minus a1, minus of minus, that becomes plus a1 minus j into, and leave this row, leave this column. When you operate this one partially with respect to x, you will get minus a2, and when you operate this one with respect to z partially, you will get minus a2 plus k into, leave this row, leave this column. When you differentiate this one partially with respect to x, you will get a3, and when you differentiate this one partially with respect to x, sorry, y, you get minus a3, minus of minus becomes plus a3. Therefore this gives you 2a1 plus a1, 2a1 into I, and it is minus of minus becomes plus, that is 2a2 into j plus 2a3 into k. And if you take 2 common, that becomes a1i plus a2j plus a3k. And since a1i plus a2j plus a3k, that is the vector a, therefore this curl of a bar cross r bar is equivalent to 2 times a bar. If you cross multiply that to on the another side, it leads 1 by 2 times curl of a bar cross r bar equal to a bar. So that is our required result. That is this. Now let us proceed to the next one. And the question seems to be like this. Prove that divergence of r bar into divergence of r raised to n into r bar equal to n plus 3 into r raised to n, where r is the magnitude of r bar. So it is not a dot product. Okay, since it is a scalar, okay, that's why it is a user product, we can say this. Now given r bar, let r bar equal to xi plus yj plus zk, and this implies r is nothing but the magnitude of r bar, that is given by square root of x square plus y square plus z square. And once you differentiate this r partially with respect to x, that is 1 upon 2 times square root of x square plus y square plus z square, and derivative of the quantity inside the root with respect to x, partially treating y and z as constant, we get to x. Therefore 2 will get cancelled, so we will get x by this square root, and this square root is nothing but the magnitude of r. That's why we are writing r bar, that is nothing but r. Therefore dou r by dou x is given by x by r. In the similar fashion, we can get dou r by dou y equal to y by r, and dou r by dou z is nothing but your z by r. Now let us consider r raised to n into r bar. R raised to n and r bar is xi plus yj plus zk. Once you multiply every term by r raised to n, we get this one. Now consider divergence of r raised to n into r bar. The divergence of r raised to n into r bar is the dot product between del and that of r raised to n into r bar. That is del, the dot product of this r raised to n into r bar is given by r raised to n into xi plus r raised to n into yj plus r raised to n into zk. Therefore, this is nothing but once you find the dot product between them, that is going to be dou by dou x of r raised to nx plus dou by dou y of r raised to ny plus dou by dou z of r raised to nz. Okay, now you go and differentiate these each with respect to x, y, z partially. Please keep in mind that r is a function of x, y, z. Okay, when you differentiate this one partially, keep the first one as it is, differentiate the second one with respect to x, that is 1, plus keep the second one as it is, differentiation of the first one with respect to x is given by n into r raised to n minus 1 into dou r by dou x. In the same fashion, we can differentiate with respect to y as well as with respect to z. Now once you simplify, you get r raised to n plus r raised to n plus r raised to n, that is 3 times r raised to n. Here n into r raised to n minus 1, and sorry, here n into r raised to n minus 1, here also n into r raised to n minus 1, n into r raised to n minus 1. If you take common, that is x into and dou r by dou x, that is x by r, plus y into dou r by dou y is y by r, and z into dou r by dou z is z by r. If it is 3 times r raised to n, this is n into r raised to n minus 1. That gives you x square by r plus y square by r plus z square by r. And now it is 3 times r raised to n. Then it is n into r raised to n minus as it is. This is r square by r. One r will get cancelled. Once you multiply, the base is same. Add the powers, you get again r raised to n. Then r raised to n, if you take common, then you will get it as n plus 3 or 3 plus n. That will be the required result. That is divergence of r raised to n into r bar equals to n plus 3 into r raised to n, where r is the magnitude of r bar and r bar is given by that is xi plus yj plus z. Again, a similar problem. If r bar equal to xi plus yj plus zk, then show that divergence of that is r bar by r is given by that is minus 2 times r bar divided by r raised to 3. Okay, where r bar equal to that is the magnitude, r is given by magnitude of r bar, or the same thing they can say that gradient of divergence of r bar by r equals to this. Now again they have given r and you have to show that gradient of this quantity is given by this thing. First, let us find the divergence of r bar by r. We know that r is xi plus yj plus zk, and r is the magnitude of r bar, that is given by square root of sum of the squares of the components, that is x square plus y square plus z square. Now r bar by r means xi plus yj plus zk divided by r. If you go for individual division, we can write it as x by r into y plus y by r into j plus z by r into k. That is nothing but f1i plus f2j plus f3. Now divergence of r bar by r is nothing but the dot product between del and that of r bar by r, that is given by the partial derivative of first component with respect to x plus partial derivative of second component with respect to y plus partial derivative of third component with respect to z, and it is partial derivative of first component is x by r with respect to x plus partial derivative of second component y by r with respect to y plus partial derivative of third component z by r with respect to z. Now let us consider uh, r partial derivative of r with respect to x, that is this one, that is given by x by r, as we did in the previous problem. Similarly, we can write the partial derivative of r with respect to y is y by r, and the partial derivative of r with respect to z is z by r. Now, once you go and compute each of these, okay, I will explain for one, it is similar for two more. Now, it is r is also a function of x, y, z. That's why let us apply the quotient rule. Square of the denominator, keep the denominator as it is. Differentiation of x partially with respect to x is 1, minus keep this x numerator as it is. Differentiate the denominator partially with respect to x, that is dou r by dou x. These two are in the similar fashion, one with respect to y and one with respect to z. Now the r square is LCM, I written as it is, r plus r plus r, that is 3r. From remaining term, if you take minus sign, we can write x, and partial derivative of r with respect to x is x by r, that I written, plus minus sign is taken out, we get plus y as it is. Partial derivative of r with respect to y is y by r, and that of partial derivative of z with respect to r is z by r. Therefore, this is 3r square minus, okay, if you take LCM, this r has to be multiplied here, that's why it becomes 3r square minus x square plus y square plus z square. The LCM r will come to the denominator, therefore denominator becomes r cube. Therefore, this is 3r square, and x square plus y square plus z square is r square. Because r is this one, if you square on both sides, we get r square equal to x square plus y square plus z square. That's why this becomes r square. If you take the simplification, that is 3r square minus r square, that becomes 2r square. And if you divide by r cube, that gives you 2 by r. This is divergence of r bar divided by r. But we want the gradient of this. Therefore, gradient of divergence of r bar by r is nothing but gradient of, and we already calculated the divergence of r bar by r is given by 2 by r. Now gradient of 2 by r is, that is del pi, and then is dou by dou x into I plus dou by dou y into j plus dou by dou z into k, and it is that 2 by r. Now take that 2 as a constant. You operate 1 by r on each of these components. We get this one. Now it is 2 as it is, and you have to differentiate this one partially with respect to x, that is minus 1 by r square, r with respect to x partially into y, minus 1 by r square, partial derivative of r with respect to y into j, minus 1 by r square, partial derivative of r with respect to z into k. Okay, now this minus 1 by r square, I will take it outside, then we find 2r by 2x into y, that is x by r into y, because we already written here, that is partial derivative of r with respect to x is x by r, and partial derivative of r with respect to y is y by r, partial derivative of r with respect to z is z by r. Just we have substituted. Again, we can take r as LCM, and it will combine with r square, it becomes r cube. Numerator becomes xi plus yj plus zk, and that is nothing but r bar. Therefore, finally we get that the gradient of divergence of r bar by r is given by minus 2 times r bar divided by r. That will be the required result. Now, there are some examples based on that irrotational vector. Now, let us go for solving of those. Now, show that f bar equal to 6xy plus z cube into y plus 3x square minus z into j plus 3xz square minus y into k is irrotational, and find the scalar potential of pi such that del pi equal to f bar. Now we have, by the property what we have stated when we have discussed that irrotational vector. Suppose the vector is irrotational, or suppose if it is a conservative field, then there exists always a scalar pi such that del pi equal to f bar. First, in this case, we have to show that the given vector is irrotational. Therefore, a vector is irrotational when its curl is 0. First, let us consider curl of the given vector, that is curl of f bar, that is given by del cross f bar. It is ijk dou by dou x dou by dou y dou by dou z, and the first component 6xy plus z cube. The second component is 3x square minus z, and the third component is 3xz square minus y. Now, if you expand this one, that is r, when this is differentiated partially with respect to, I will get minus 1, minus, if you differentiate this one partially with respect to z, you get minus 1 minus of minus becomes plus 1, then it is minus j. Leave this row, leave this row, and leave this column. When you differentiate this one partially with respect to x, you get 3z square, minus when you differentiate this one partially with respect to z, then you'll get minus 3z square. Then it will be plus k to leave this row, leave this column. Differentiate this one partially with respect to x, that is 6x, minus differentiate this one partially with respect to y, again that leads to 6x along with the minus sign. Now these will get cancels, this becomes 0. Here curl of f bar is 0, that's why we can claim that the given vector f bar is irrotational. Now from the property, whenever the vector is irrotational, there exists a scalar pi such that del pi equal to f bar. Now del pi means dou pi by dou x into y plus dou pi by dou y into j plus dou pi by dou z into k equals to, that is the given vector f bar you are written here. Now equating the coefficients of I, j, k on both sides, let us see what we get. First, the coefficient of I on LHS is dou pi by dou x, and that one equals to, say on RHS it is 6xy plus z cube. Now if I integrate this one with respect to x in order to get pi, we get, that is 6y means 6y is a constant, x with respect to x is x square by 2. That's why this becomes 3x square y. If I integrate this one with respect to x, treating others as constant, that becomes z cube into x plus. And please keep in mind, while finding this pi with respect to x, we have treated y and z as constant. When we integrate the same thing with respect to x, actually we have tried here constant plus constant. Now that constant we are taking as a function of other two variables, that is y and z. Now the second one, equating the coefficient of j, that is dou pi by dou y, and now this will be 3x square minus z on RHS, that's the coefficient of j. Now if I integrate this one with respect to y, in order to get pi, you'll get pi on LHS. If we integrate this one with respect to y, you'll get 3x square y minus zy plus, again I would write the constant, and here the constant is other function of other two variables, that is x and z, that is f2 of x and z. Similarly, the coefficient of k on LHS is pi with respect to z. Okay, then RHS is 3xz square minus y. If we integrate with respect to z, now pi equal to, that becomes with respect to z means z cube by 3 will get cancelled, it is xz cube minus yz plus, in this case it is integrated with respect to x, because while finding this we have treated x and y are constant, that's why the whatever the constant of integration is there, that we are going to take it as a function of x and y. Now we got the three expressions for pi. Now in order to get a unique expression for pi, okay, we have to get a unique expression for pi. Therefore, we have to choose these f1, f2, f3 suitably so that we get a unique expression for pi. Okay, and there is a trick how to choose those f1, f2, f3. Now, when you are choosing f1, look into the other two expressions and you have to choose the functions of y and z which are not in this particular expression for pi. Therefore, in the other two, to see the other two, what are the functions of y and z which are not here? That is only one thing, that is minus yz. Therefore, I have taken f1 equals to minus yz. Now, when you are choosing f2, look at the other two expression for pi. Choose the function of x and z which is not here. Therefore, what is that function of x and z which is not here? That is nothing but your xz cube. That's why we are going to choose f2 as xz cube. Now to choose an expression for f3, look into the other two expression of pi. Choose the function of x and y which is not here. That is 3x square y, which is a function of x and y which is not here. That's why we have chosen f3 as 3x square y. Now you substitute either f1 in this one or f2 in this one or f3 in this one. We are going to get an unique expression for pi as 3x square y plus xz cube minus yz. This will be the unique expression for pi, and this is called the required scalar potential, we can call it as. Now let us consider a similar example which appeared in the model question paper, and the example is like this. Find the values of a, b, c such that the vector axy plus bz cube into I plus 3x square minus cz into j plus 3xz square minus y into k is conservative for force field, and hence find the scalar potential phi such that del phi equal to f bar. Given that f bar is a conservative field, means the vector is irrotational. That's why we find the curl of f bar equals to 0. First, let us find the curl of the given vector. That is curl of f bar equal to del cross f bar, and that one equal to ijk. The first, second row elements are dou by dou x, dou by dou y, dou by dou z, and the third row elements are the components of f. The first component is axy plus bz cube. The second component is 3x square minus cz, and the third component is 3xz square minus y, and the curl of f bar is 0. That's why we are equating that one to 0. Once you expand this one I as it is, differentiate this one partially with respect to y, that is minus 1, and differentiate this one partially with respect to z, that becomes minus of minus, that becomes plus c, minus j into, leave this row, leave this column, differentiate this one partially with respect to x, that gives you 3z square, and differentiate this one partially with respect to z, that becomes minus 3bz square, plus k into, leave this row, leave this column, differentiate this one with respect to x, that is 6x, minus differentiate this one with respect to y, minus ax, and that one equal to 0. 0 k is, it is a vector, that's why I can write it as 0 vector. 0 vector can be written as 0 into I plus 0 into j plus 0 into k. Now equating the coefficients of I, j, k on both sides, we find minus 1 plus c, that is nothing but c minus 1 equal to coefficient of I, that is 0. When you come across with this one, this becomes 3z square minus 3bz square. Again, it is 0. Next one is 6x minus ax equal to 0. Once you get this one on the other side, that gives you c equal to 1. This gives you 3z square equal to 3z square into b. 3z square will get cancelled, b equal to 1. And if you take this one on the another side, that is 6x equal to ax, x will get cancelled, so we find a equal to 6. Once you substitute the values of a equal to 6, b equal to 1, and c equal to 1 in the given vector, that is 6xy plus z cube into I, and next one is 3x square minus z into j, and last one is 3xz square minus y into k. And this is nothing but the same vector what were discussed in the previous problem. And again, to find the scalar potential for this one, we have to execute the same steps from this particular step onwards. That's why I have written here, that is to find the scalar potential phi such that del phi equal to f bar, you have to refer these steps from the previous example, from this step to this one. Now, because one thing I want to explain here one more time, when you get three expressions for pi, we have to get a unique expression for pi. Now, in order to find the unique expression for pi, we have to choose the values of f1 and f2 and f3 suitably. And there is some trick, and I'll explain that trick one more time. When you're choosing the value of f1, to look at the other two expressions for pi, choose the functions of y and z which are not in this one. Now, when you are choosing the f2, you look into the other two expressions for pi and you choose the function of xz which are not here. And when you are choosing f3, look into the other two expressions for pi and you choose the function of xy which are not in this one. That's a way, or that's a trick to choose the values of f1, f2, f3. Now, let us go to one more example. Here, the example is like this. Find the values of A, B, C so that the directional derivative of pi equal to ax square, ax y square plus byz plus cz square into x cube at this point, that is 1, 2, minus 1, has a maximum magnitude of 64 units in the direction of z-axis. Okay, now here our job is to find the values of A, B, C which fulfill the given criteria or given situation. First, let us find the directional derivative, and they have given the directional derivative is as a maximum value 64, and that is in the z direction. And in the z direction, the unit vector is taken as k, because as we said in the beginning only, ijk represents the unit vectors in the direction of the coordinate axis x, y, z respectively. Since in this case they are given the maximum directional derivative is 64, and that is in the z axis, along z axis. That's why del pi at the point P in the direction of that unit vector along the z axis is k cap x, or k we can write k equals to 64 units. Now, first let us find del pi for the given scalar. Del pi is given by dou pi by dou x into I plus dou pi by dou y into j plus dou pi by dou z into k, and the point P is given as 1 to minus. If we differentiate this one partially with respect to x, we can write it as ay square plus, that is 3c z square x square into I, plus if we differentiate this one with respect to y, that is 2axy plus, that is with respect to y is bz, and here there is no y, it's 0 into j, plus when you differentiate with respect to z, here there is no z, its value is 0. When you differentiate with respect to z, here we get by, plus if you differentiate this one with respect to z, that is 2cz into x cube into k. And now we have to calculate this del pi at the given point, that is 1, 2, minus 1. If you take these values 1, 2, minus 1 for x, y, z, we get here it as 4a plus 3c into I, plus here if you take x equals to 1, y equal to 2, z equal to minus 1, you get it as 4a minus b into j, plus if you take x equals to 1, y equal to 2, z equal to minus 1, here it will give you 2b minus 2c into k. Now they have given del pi dot, because the directional derivative is maximum and it is equals to 64. That's why that is del pi at p into means dot product with respect to k equals to 64. That's why here del pi with respect to k only we are going to get, because the respective components, the component of k, this k can be written as, that is 0 into I plus 0 into j plus 1 into k. Once you take the dot product, this into 0 is 0, this into 0 is 0, plus, and this into k is 1. That is what 2b minus 2c equals to 64. And now this will be equals to, that is if you take 2 as common term, if you cross multiply, you will get b minus c equals to 32. And let us take it as equation 1. Since one thing they have given that the directional derivative is along z-axis, that means the x and y components of del pi at p must be 0. We already got the del pi at p, and since it is along the z-axis, that's why x and y components must be 0. X component is, that is 4a plus 3c equals to 0, and y component is 4a minus b equals to 0. Since you have taken this one as 1, let us take this one as 2 and this one as 3. And this implies b equal to 4a. Now, using this in equation 2, we get that is 4a is b, that is b plus 3c equals to 0. Now, let us call it as equation 4. Now, equation 1 and 4, they are the two simultaneous equations in terms of b and c. By solving them, we get c equals to minus 8 and d equal to 24. And now, taking the value of b equal to 24 or c equal to minus 8 in any one of these equations, we are going to get the value of a. Therefore, from equation 2, okay, that is here, we have the value of a as, that is, I think, equation 2. What is that equation 2? This one. From this one, we have this thing. Therefore, we can write that a equal to b by 4 we can write, and that will be a equal to b is 24 divided by 4. That leaves a equals to 6. Now, using the given information, we got the values of a, b, c as a equal to 6, b equal to 24, c equals to minus 8. Here, the important thing you have to note that del pi at p dot k cap is this one because it is a dot product and this is k is also vector, and that vector unit vector k can be written as 0 into I plus 0 into j plus 1 into k. Taking like that, once you go for calculation of dot product by taking the sum of the product of respective components, we are going to get this. That is the thing we have to keep in mind. Since the directional derivative is along z-axis, therefore the x and y components of del pi at p must be 0. That's why we have taken these two as 0. And by taking some calculation, okay, we get the values of a as 6, b as 24, and c as minus 8. Now let us go with one more last example in this case. Okay, and the example is like this. Find the values of a and b such that the surfaces ax square minus byz equals to a plus 2 into x and 4x square y plus z cube equals to 4 are orthogonal at the point 1, minus 1, 2. Now they have given some information that these two surfaces are orthogonal at this point. Using this information, we have to find the values of a and b, and it is there in the model question paper. And now, in order to go for finding the values of a and b, first of all, we have to ensure that the given point, that is 1, minus 1, 2, lies on both the surface. That's why substitute x equals to 1, y equal to minus 1, and z equal to 2 in both the equations of both the surfaces. And let us take pi 1. This one, let us take it as pi 1, and this one, let us take it as pi 2. Once we take the values of x, y, z as 1, minus 1, 2 in both pi 1 and pi 2, we get in the first one, that is, if I take x equals to 1, this becomes a, and this becomes y equals to, y and z, that becomes minus 2 minus of minus, that is plus 2b equals to, if I take x equal to 1, that becomes a plus 2. And now if we simplify this, a will get cancelled. We find 2b equal to 2. Where 2 will get cancelled, we will find b equals to 1. When we substitute that one in first surface equation, the first surface. When we take the same value point on the second surface, it satisfies and it will give 4 equal to 4. That means LHS equals to RHS. That confirms that 1, minus 1, 2 satisfies the second surface. Therefore, that point P lies on the second surface, and this point P lies on the first surface also when B takes the value 1. That's why it is a thing to be noted. Now we know one thing, that is B. Now we have to find another value, that is A. And in order to find the value of A, we have to use one more information, that the given two surfaces intersect orthogonally. That means theta equals to pi by 2. Now we have an expression for angle between two surfaces as cos theta equal to del pi 1 into del pi 2 divided by modulus of del pi 1 into modulus of del magnitude of del pi 2, and that one equal to cos pi by 2, that is 0. If you cross multiply, this leads the dot product of del pi 1 into del pi 2 equals to 0. Now let us refer it as equation 3. Now pi 1 is ax square minus this one ax square minus byz minus a plus 2 into x, that is pi 1, and pi 2 is given by 4x square y plus z cube minus 4 to take all on another side. Now del pi, that is 2 pi 1 with respect to x partially, do pi 1 with respect to y partially into j plus do pi 1 partially with respect to z into k. Now when you go for partial derivative of pi 1 with respect to x, here we'll get 2ax, and it is free from x, it is 0, and this becomes minus a minus 2 into I. When you go with respect to y partially, that becomes minus bz into j. With respect to z partially, that becomes minus by into k. And the same fashion, when you go with respect to second surface, we get it as 8xy into I, and it is 4x square into j plus 3z square into k we get. Now these del pi 1 and del pi 2 at the given point 1. What is the point? The point is 1 minus 1, 2. Means they are the values of x, y, z. If we compute these del pi 1 and del pi 2 at the point P, we get it as a minus 2 into I minus 2j plus k. Just to substitute x equals to 1, y equals to minus 1, and z equals to 2 here and here. We are going to get this one from this one. Once you take the same points here, we get it as minus 8i plus 4j plus 12k, because here b is involved and we already computed the value of b as 1. Therefore, if you take b equals to 1 here, we are going to reduce this one to this particular form. Now that equation 3, the dot product of between del pi 1 and del pi 2 is 0. Once you go for that, this becomes the dot product, that is minus 8 into a minus 2, and it is minus 8, and this is plus 12, and RHS is 0. That's why I have taken it as 0. Therefore, it is minus 8a plus 16 minus 8 plus 12 equals to 0. If we simplify this, that will be 28 minus 8, that is 20. That is 8a equal to 20 you will get. Therefore, it leaves a as 5 value. That will be the required values of a and b. And this is all about the basic concepts of vector calculus, in particular vector differentiation. And we have considered some examples on vector differentiation. In the next video, we have to discuss about vector integration. And in that vector integration, we come across with many concepts. First one, line integral of vectors. Next one is Green's theorem in plane. Next one, Stokes theorem, and one more, Gauss divergence theorem. These are the things to be discussed under the category vector integration, and that we can discuss in the upcoming videos. Thank you.